The first section of Unit 3 was comparing the amount of particles, so the moles of them, to the actual number of particles, so the physical counting number of it. The second section is on the relationship between the mass of a substance and the number of moles of it. This is actually an extremely convenient way that chemists use to determine how much stuff do we actually have, how many physical particles are there. So to begin with, think of atoms as actually different things. If you have 12 limes and 12 eggs, they're not going to have the same mass. In a similar way, if you have something like hydrogen gas, H2, which is a very light gas, if you have 1 mole of that, it's not going to have the same mass as 1 mole of, this is glucose here. It's going to have a different mass. Okay, so H2 is not going to weigh the same amount as C6H12O6 if you have 1 mole of both of those. So how does the mass of one atom relate to the mass of 1 mole of that atom? So if I have 1 mole of it, how much does it weigh? So this goes back to our definition of what a mole is. We said this yesterday, that a mole is exactly 12 grams of carbon-12 atoms. Okay, so exactly 12 grams. The mass in grams of 1 mole of any pure substance is called its molar mass. Okay, you're going to hear this term now all the way to the end of the year, molar mass. Molar just meaning per mole, for 1 mole. How much does it weigh for 1 mole? Well, if you don't have your purple periodic table sheets with you, you should probably go ahead and get those out because you're going to need those handy for the rest of this section. The molar mass of any element is numerically equal to its atomic mass and has the units grams per mole. So if you're looking at your periodic table for hydrogen, okay, its atomic mass, all right, in your top left box will say 1.00795, and the units that we had for that previously were AMUs, atomic mass units. Okay, well that also turns out to be this substance's what's called molar mass, 1.00795 grams per mole. What does that mean? Well, if I want 1 mole of hydrogen atoms, that is going to equal 1.00795 grams of it. So if I had a scale that could magically measure out 1.00795 grams of hydrogen, I would have exactly 1 mole of it. If I go down the table just once to lithium, lithium has an atomic mass of 6.941 AMUs, atomic mass units. So this is for lithium here. Okay, this one over here is hydrogen, just so we're clear. Well, that's also the same as its molar mass, 6.941 grams per mole. So if I want 1 mole of lithium atoms, I need to weigh out 6.941 grams on a scale. So, what does this look like? Well, here's an example using iron. Iron on your periodic table, element 26. Its molar mass, 55.845. Okay, well, if we go with atomic mass, 55.845 AMUs. Well, that's equal to its molar mass, 55.845 grams per mole. So if I want exactly 1 mole of iron atoms, and remember we said this yesterday, this is 6.02 times 10 to the 23rd, okay, in this case atoms per every mole, atoms per 1 mole. Okay, if I want roughly that many, remember we're dealing with significant figures here, but within 3 significant figures, if I want 1 mole of iron atoms, I need to weigh it out on a scale close enough to 55.845. So over here on this side, on the right, okay, there's a watch glass on there that they would have zeroed it on, and they've put 55.85 grams of iron on the scale. So that's approximately what 1 mole of iron atoms would look like. So now you have a relative idea about the size of things, at least when it comes to metals and how much space they take up. Okay, but this is 1 mole. That's roughly this many number of atoms right there. So let's say you are performing a reaction and you need exactly 2.5 moles of aluminum. Okay, so we'll get to a point this year when we are doing labs that you need to know exactly how much of a chemical you need. The number of moles times the mass in grams divided by 1 mole, sorry, this kind of got shifted over here, it should be right there, is equal to its mass. So, in fact, we can just go ahead and show you what this looks like down here at the bottom. All we are doing, we are using dimensional analysis to cross off units. Okay, if I have, and I want 2.50 moles of aluminum, okay, and I need to figure out how many grams of aluminum I need, I go over to my periodic table to element 13 to aluminum, and I see that its atomic mass is 26.9815. Well, for our purposes, and you can make a little note of this up here, we will round all molar masses to the hundredths place. Okay, so that's 26.9815 AMUs. We will write that as 26.98 grams per every 1 mole. Well, now look what happens to my units for moles. They are going to cancel out. I'm left with a unit of grams. Okay, so if we're doing this, we're going to need 3 significant figures. You get 67.4 grams of aluminum. Okay, so if I want 2.5 moles of aluminum, I need to weigh out 67.4 grams of aluminum on the scale. Notice, okay, the amount you weigh out on the scale is going to change based on what this substance is, okay, what this substance's molar mass is. Okay, if you noticed earlier just a moment ago with the iron, 55.85 or so grams of it was 1 mole. Well, 67.4 grams of aluminum is 2.5 moles. So it depends upon the molar mass of that element or molecule or compound, whatever we've got there. So this question says, what is the mass of 2.15 moles of silver atoms? So start with what we were given. We were given 2.15 moles of silver, like that. I want to get rid of moles of silver and turn it into grams of silver. To do that, I need the molar mass of silver. And you're going to see this abbreviated as a cursive capital M, okay? So in the future, when it's asking about molar mass or it gives you a molar mass, you will see it as a cursive capital M is what it will look like. Okay, so we look at silver element 47. Okay, it is 107.868 AMU, so if we're turning that into a molar mass and rounding to the hundredths place, that is 107.87 grams per mole. Well, up here, which one are we going to use? Are we going to write grams over moles or moles over grams? We want moles on the bottom, so we're going to keep it like it is right there. We have 107.87 grams per every 1 mole for silver. Okay, is equal to, so we got 2.15 times 107.87. Okay, and we only need 3 significant figures here. This one's got 5, this one has 3. So my answer here is 232 grams of silver. Okay, is the answer to that problem. We only need 3 significant figures. So here's an interesting one. What happens when we start getting compounds? Something like this one, CH4. This, by the way, is a compound called methane. This is natural gas, methane. Okay, CH4. Well, it's easy when you have an atom, but what happens when we have a molecule like we've got over here? Well, let's just start with what we were given. The mass here was 4.25 moles of methane, formula CH4 like that. We want to figure out what is its mass. Well, to do that, we need the molar mass of methane. I'm going to write it as a subscript there like that. What's the molar mass of methane? Well, for the other ones, for the atoms, you just look on the periodic table, find the atomic mass, convert it into grams per mole, or its molar mass, which is very easy to do because it's the same number. What happens when you have a compound? Well, in this instance, you need to add up the molar mass of every single atom involved in that compound. That will be the molar mass of the whole thing. So carbon element 6 has got a molar mass of 12.01 grams per mole. Okay, and we've got 4 hydrogens, so we're going to add to that 4 times, okay, the molar mass of hydrogen rounded to the hundredths place is 1.01 grams per mole. Okay, and this whole thing, 12.01, basically plus 4.04. Okay, this is going to equal 16.05 grams per mole. That is the molar mass of methane. So we come back up top here to find out how much it weighs. I want to put the moles on the bottom, just like we have down here. So we're going to multiply by 16.05 grams divided by 1 mole, right? That's how many grams you have per mole. So times 4.25. Okay, we only need 3 significant figures here because of that number, and we're going to get 68.2 grams of methane. Okay, that is my answer. That is how you solve that. So if you've got a compound, and this is important because you'll see this again, do it like that. Okay. So here are just some additional practice problems. How many atoms are there of zinc in 47.45 grams of zinc? Well, what I'm going to do, because this looks like a whole mess, I'm just going to do this on a new slide. So I have 47.45 grams of zinc, and I want to figure out how many atoms is that. So we had 47.45 grams of zinc, okay, and we want to figure out how many atoms. That's our goal, how many atoms? Well, we're given grams. We don't have a direct conversion between grams and atoms, but we do have a middleman here, and that would be the unit of moles. So if I have 47.45 grams of zinc, okay, and I want to get that over to atoms, I'm going to need the molar mass of zinc. Well, from your periodic tables, that is 65.38 grams per mole. Okay, well, here, since I have the grams on the top, I'm going to need to flip that. I need the inverse of it. So times 1 mole divided by 65.38 grams. Okay, so now my units of grams is going to cancel. All right, and I end up with moles, and I'm still not quite, because I'm looking for ultimately how many atoms do I want. Well, we just learned this last time. What's my conversion to get over to that? Well, that's using Avogadro's number. I'm going to put the 1 mole down at the bottom. And at the top, I have the 6.02 times 10 to the 23rd, and here we have atoms is what we are looking for. Okay, and now my problem is set up, and I'm going to go ahead and cross out my units that are getting canceled, and I suggest you do the same because otherwise it is going to be hard for you to keep track of everything you need to do. So 47.45 divided by 65.38 times 6.02 times 10 to the 23rd. Okay, and we end up with 4.37 times 10 to the 23rd atoms of zinc. Okay, that is my answer. I've only got 3 significant figures in Avogadro's number. Okay, there's more to it, but we've rounded it off, so there's only 3 in my answer here. Okay, how many atoms are there in 94.2 grams of carbon? Not sure if we need to do that. How many molecules of, this is ethene, are there in a 2.5 gram sample of it? Okay, we'll do this one and then we'll call it a day. So my formula here, C, whoops, let's change this back to white so we can read it. There we go. So we get C2H4. I want to find the molar mass of that. Well, we're going to have 2 times the mass of a carbon atom. Well, the mass of a carbon atom is 12.01 grams per mole. Plus, we got 4 times the mass of a hydrogen atom, 1.01 grams per mole. Okay, is equal to, so 12.01 times 2 plus 4.04, and that is 28.06 grams per mole. That's the molar mass for ethene. Okay, I've got the grams. I want to figure out how many molecules. Well, it's very similar to what we've just seen. You get 2.50 grams. Okay, if I want to get rid of grams, I need to put the grams on the bottom of my next conversion factor, so 28.06 grams per every 1 mole. Gets reversed like that. And if I'm trying to get over to the number of molecules, 6.02 times 10 to the 23rd molecules. This is why we label everything. It's going to be very difficult if you don't do this. You're not going to be able to follow along very easily. And let's just double check to make sure all my units cancel. Grams cancels, moles cancels, left with number of molecules. That's what we're looking for. 2.5 times, they're divided by, 2.50 divided by 28.06 times 6.02 times 10 to the 23rd. And that is 5.36 times 10 to the 22nd molecules of C2H4. Okay, that would be the answer to that problem. So let's take a look at some of the ones on your homework, just so we got you off on the right foot. On page 2, okay, so 1 through 10 is asking you to find the molar mass of something. Say for number 1, it's looking for chromium. The molar mass there, well, that's just straight off your periodic table. We're going to round it to the nearest hundredth, as it says in the directions. Okay, that's going to be, well, look, this is an interesting one. Before we rounded, it's 51.9961 grams per mole. And if I'm going to round this to this place right here, okay, I look at this 6. The 6 tells me this number is going up. Well, if that number goes up, so does that one. All right, so what my answer is here to the 10th place, it actually comes out with the right number of significant figures, 52.00 grams per mole. So make sure you're careful with that there. Okay. One like, let's look at number 8. A compound, NaCl. Okay, molar mass here, we got to add up each of the atoms involved. I have 1 sodium atom. We've got 22.99 grams per mole. Okay, plus the amount from chlorine, 35.45 grams per mole. Okay, so 22.99 plus 35.45, and that is 58.44 grams per mole. So that would be your answer there for that one. Okay. On 11 through 20, just a sample here, number 11, we have 2.31 grams of iron. I want to turn that into, it says here, number of moles of the substance. Okay, so in this case, in order to convert this over, I need the molar mass. Well, that's from your periodic tables. Iron to the 100th place, 55.84 grams per mole. Okay, so if I want moles, I got to get moles on the top, so 2.31 grams. Okay, if I'm multiplying by things here, the conversion factors, the 1 mole's got to be on the top, which means the 55.84 grams has got to be on the bottom. So I'm really dividing here, 2.31 divided by 55.84. And with 3 significant figures, I have 0.0414 moles of iron. Okay, don't let that scare you. That's the answer there, 0.0414 moles of it. So if I weigh out 2.31 grams, that's how many moles I have of iron. Okay. Everything else there is either a problem that we've done or things that you should be able to figure out there on your own. So go ahead and give page 2, 3, and 4 a go.